My name is David Yenerall. I'm a lecturer of astronomy here at Georgia Primitive College, now Georgia State University, and I'm also a NASA Solar System Ambassador. So I get to go out on behalf of Jet Propulsion Laboratory and NASA and give public talks about their various missions. So today I'm going to be talking to you about a very exciting mission, New Horizons. I spoke about this recently, several months ago, and I'm here now to give you an update. So let's see, this picture here, this is an artist's rendition of Pluto, okay, and it's not too far from reality. Okay? It's a very icy scene, and this is a picture of New Horizons over it, not the scale, of course. And if you notice in the upper right-hand corner, see that star? That's the sun. Okay, it looks very dim, doesn't it? Okay, well, Pluto is very far away from the sun. Okay, how many of you are astronomy students? You're a very good astronomy student, so you'll probably know what I'm talking about. The inverse square law. Okay, it states that the further away we are from an object that emits light, the dimmer that object is. But it's not just like if we were double the distance away from the sun than we are here at Earth, say we were at 2 astronomical units rather than 1 astronomical unit, it wouldn't be twice as dim. It would be a square of the distance. It would be 4 times dimmer. Okay, if we were 3 times further away, or 3 astronomical units, how much dimmer would it be? 9 times dimmer. 4 times? 16? Okay, great, you guys got it. So Pluto is 33, at this time it's 33 astronomical units away from the sun. Okay, so a little over 1,000 times dimmer. So that's why they've made it look like a little dim little spot there. And we'll talk more about that in a few minutes. Okay, so this is an illustration of the orbital cycle of Pluto around the sun. Okay, it takes 248 years for Pluto to orbit the sun one time. Okay, it was discovered in 1930 by Clive Tombaugh. And if you notice, they started planning the New Horizons mission when it was at perihelion. It was close to the approach to the sun. And they actually embarked upon the New Horizons mission before it even made one orbit around the sun from the time that they discovered it. So it's a really big deal for human beings. We should be impressed with ourselves. Okay. Yes, exactly. Okay. So this animation here, okay, shows you Pluto and its orbital path around the sun being at the center of the image, and those little dots that are showing up all around it. Those are Kuiper belt objects. The Kuiper belt is a ring, or a torus actually, of icy, rocky bodies that are the original material from which our solar system was formed. And they reside outside of the orbit of Pluto. Well, actually, outside of the orbit of Neptune. Pluto, since 2006, is considered one of these Kuiper belt objects. It's been demoted from planet status to a dwarf planet status. So if you notice, it tilted and showed us the profile of the Kuiper belt. And these things are above and below the orbital plane of the planets around the sun. It's thought that this Kuiper belt formed when Uranus and Neptune migrated outward from the solar system, from the inner solar system, scattering these building blocks outward. Yeah. Oh. Maybe. There we go. Here we go. Got it. Okay, so here's Pluto, and then as they discover these Kuiper belt objects, we now know of a couple thousand of them that are out there, and we're going to be learning about more and more as we get more observations of this area of the sky, this area of the solar system. Okay, so they're all objects that are outside of Neptune's orbit. And then when we look at the side of the orbital plane, we can see that they're scattered upward, downward, and all around. Okay. So these are Kuiper Belt objects here. Okay, this is a sampling of some of the bigger objects that are out there. Okay, if you notice, some of them they have funny names, like Maki Maki. They have all different funny shapes, different colors. There's a large number of them, and there's a large variety of objects and types of objects out there. Okay, and then we have some asteroid belt objects also. Okay, this is the biggest one, Ceres, and we recently sent a spacecraft called Dawn out to the asteroid belt to study Ceres. Now, the asteroid belt is more rocky and metallic objects that are also building blocks from the early solar system, and they reside between Jupiter and Mars in the inner portion of the solar system in a belt. So Ceres is the largest object in that asteroid belt. It's comparable in size to Pluto, and it looks a lot like what they expected Pluto to look like. Okay? A round object covered in impact craters. So this is a scale representation of Pluto's main moon, Charon. And here's Pluto over here on the right, and here's the Earth. Okay, the Earth is 457 Plutos by mass, and Pluto's moon Charon is 1/8 of Pluto. Okay, and so these two objects are they're in spin orbit phase lock. So what does that mean, spin orbit phase lock? Well, luckily we have some volunteers here. We have some people in blue suits and people in red suits. And to demonstrate, the people in blue suits can always see the other object. The people in the red suits can never see the other object. Okay. And also the moon Charon, from the perspective of the people in the blue suits, the moon would go through all the different phases, but it would always be high, directly over their heads in the sky. Okay. All right. So from Earth, this is the very, very best we can do as far as imaging Pluto is concerned. Okay, what does it look like? A blur, that's good, like a spotty object spinning around in space. This is the best we can do, even from the Hubble telescope from Earth. So people were very interested in learning more about Pluto and getting some better images, especially planetary scientists. Okay, so we knew just from these poor images that that Pluto is reddish and Charon is gray colored. Okay, they're estimated to have a density that's consistent with 50% rock, 50% ice. And if you notice in the lower right-hand part of the screen, we have the surface temperature of Pluto listed in all different scales. But one thing they have in common is they're all very, very, very cold, no matter what scale you use. Okay, and this is a picture of Alan Stern and Fran Bagenal. These are the co-investigators who are in charge of the New Horizons mission. They came up with the idea in 1989 to have a mission of this sort. It took several studies, several attempts to get NASA to agree to a mission to Pluto. People just were not very interested in it at this time. It took until 2001. The public finally got behind them, and they started designing and planning of the mission. Okay. So this is a picture of New Horizons. It's about the size of a baby grand piano. Okay, it's a lot smaller than many of the other spacecraft that NASA has launched. They wanted to get it there very fast. Okay, so I'm going to go through the different parts and different instruments on it. You see that thing at the bottom on the left sticking out? Right here? Okay, right here. This thing is where the power comes from. Okay, the electricity to power all the instruments on board New Horizons. The way it works is there's an isotope called plutonium-238. Okay, plutonium-238. Do you think I have some in here? I wish it was coffee. I would be drinking it. No, it's hot water, but we're going to pretend like it's plutonium-238 because it's going to do pretty much the same thing as the plutonium would do. It's going to release heat when I take it out of this container. So I'm going to show you how the spacecraft makes electricity. Okay. See that steam? Nice. Okay, so this is a Stirling motor, or Stirling engine. Stirling engine is powered by heat. There we go. Come on. Powered by heat. So the heat coming up from the thermos lifts this piston, makes this wheel turn. The inertia of the wheel turning pushes the piston back down. Heat causes it to rise back up. And it takes a very, very little amount of force to make this thing turn. Okay, so they have something like this. I'm sure it doesn't look like this one, but something like this mechanism on board, and it's right here. So, okay, we have a wheel spinning. How does that help us do anything? Well, it helps us do everything, exactly. So this is a generator. So there's a generator, something like this on board, and when we turn the wheel, that allows us to turn this armature. If we turn an armature, electricity. So look at that thing go. I'm just gonna let that just go. This is about $200. I've actually done projects with my honors class where I had them bust apart a cassette player and get out the gears and belts, and I use soup cans and make their own Stirling engines, and they've had a great deal of success with it. Okay, so all right, that's obviously this was my favorite part of the spacecraft. I love that they can do this. But they're the instruments. This is what's important to the planetary scientists. We have LORRI. Okay, LORRI is a long-range, high-resolution black and white camera. Okay, RALPH is a color camera, and they use it to look at the surface of the planet and try to discern the surface composition. There is ALICE. ALICE studies UV sunlight coming through the atmosphere and allows them to understand the composition of the atmosphere. There's a 6-foot radio dish on it, the round thing on the back. That's called REX. REX studies the occultations of the ionosphere and the atmosphere at radio wavelengths. SWAP and PEPSI, they study the solar wind, the charged particles that leave the sun and go through our solar system. It interacts with the atmosphere and the ionosphere, and they study this with these two instruments. And the most important instrument of all is the student dust counter. Okay, so these are the students at Colorado University at Boulder, and they designed, built, tested, operated, analyzed the data coming down from this thing, University of Colorado Boulder, and what they did is they wanted to study the distribution of dust in the solar system and in the vicinity of Pluto. Dust can be formed when Kuiper Belt objects bump into each other, so they're going to continue to use this instrument as they go further out into the solar system. But the results were they found about 1 particle every 3 days. So they're going to see if that gets higher when we get into a more active part of the solar system. Okay, so the big day, launch day, January 19th, 2006. The students were there, and NASA put this thing on the largest rocket they could get their hands on so they could get it there very quickly. Okay, in the meantime, a few months before launch, they discovered 2 new moons, Hydra and Nix. And a couple months after the launch, they found 2 more, Kerberos and Styx. Okay, and they were worried about debris and dust in the system as New Horizons flew through because of these new objects. They may have been causing material to accumulate in the near Pluto environment. But luckily they were able to adjust their trajectory enough to where they could get pictures of all 4 of these moons as they're going through the system. Okay, so it's a 9.5-year journey. It just kind of gives you a sense of the scale. This thing was traveling at 33,000 miles per hour. It did get an assist, a gravity assist, when it flew by Jupiter in 2007, and that saved it 3.5 years of travel time. Okay. So, all right, let's take a second to discuss, where do these icy objects come from, and why do we care? Okay, so planetary scientists definitely care, but we want to know how the solar system formed, so this can give us insight into that process. They want to know, there are some mysteries, like why were these type-field objects kicked out? How do planets form from clouds of gas? Okay, that's a pretty big mystery. Right now, we have the condensation theory. This is the classic textbook explanation of how the solar system formed. Okay, we start off with a nebula or a cloud of gas and dust. It collapsed. It spun up. Okay, the rocks and the metals, they were able to condense close to the hot sun, and the ices and other metals condense further out where it's colder. Okay, and that we come up with these ideas of formation so that we can make predictions. Okay, we can make predictions about the fate of our own solar system and about the behavior of extrasolar systems that we're searching for right now. Okay, so this gives you an idea of the scale of the different sizes of the different planets in the solar system. The ones very close to the sun are rocky planets. Okay, they're made of silica and metal. Now in the universe, because for these heavier elements to exist, hydrogen has to have undergone processes inside the core of stars. So there's less of these heavier elements in the universe. But look at Jupiter, Saturn, Uranus, Neptune, these big gaseous giants. These are made mostly of hydrogen. And hydrogen is very abundant in the universe. So we can actually see that in the scale of the planets in our solar system. But it's not so simple. Okay. How are Uranus and Neptune where they are at the age of the solar system? We would expect the solar system to be older in order for these objects to be so far away from the sun. There are problems. There are problems with the condensation theory. It often relies on catastrophic events to explain the situation that the planets are in. So they tried, over the past 15 years, they've been toying around with a new computer modeling system where Uranus, Neptune, Jupiter, Saturn, they're all between where Jupiter and Saturn reside now. And then they took planetesimals, the building blocks for planets, and scattered them all throughout the solar system. Guess what happened after about 1 million years when they ran this simulation? I'll tell you. Okay. In an interaction with Jupiter, Uranus and Neptune are kicked out to where they are now, and it scattered planetesimals out into the Kuiper Belt where we see them. Okay. It also scattered some of the planetesimals into the inner solar system and gave us the material for the terrestrial planets to form. And it delivers water to Earth. It gives a mechanism that would be a reasonable way to explain why we have water on Earth. It's just a model. Oh, I'm sorry. Let's see. Oh, here it's okay. Yeah, it's not doing anything. It's just it would. I think it's supposed to do something, but it's not working. Okay. I think it's supposed to scatter Uranus and Neptune and then show us all the planets what's going out with. Okay. So this is why we want to study Pluto. Finding out what Pluto is like, we'll test out some of these ideas. Okay, we find out what it's made of and what some of the other Kuiper Belt objects are made of. We can decide if this is a viable alternative theory. Okay. All right. So the biggest milestone of all is July 14th, 2015. After 26 years of working on this mission, 9 years of flight, 3 billion miles to Pluto. They flew through the Pluto system, and it only took 2 hours to fly through. Okay, this is the trajectory. Okay, and it's a 4.5 hour one-way communication with Pluto. So we can't control it from Earth. We can't tell it, hey, take a picture of this, take a picture of this, turn here. It had to know everything it was going to do ahead of time. It's programmed with algorithms that let it react to things that might happen, and also to fly its flight plan and take the proper pictures. Okay. So this is a movie showing how the pre-programmed robot spacecraft made observations. Now this is sped up. 10 minutes only takes 1 second in this video. Okay, so it flies into the Pluto system, taking pictures of Pluto and its moons. And then after it flies through the system, it turns around and it takes a picture of the planets with the sun in the background, so the sun can light up the atmosphere and they can study the atmosphere. Okay. So okay, these are some typical questions that people would like to discuss. Right, and maybe you guys can help me out with this. Why not stop at Pluto? That's right, it's going way too fast. If you're going 33,000 miles per hour, it's hard to put on the space brakes. You have to put as much force backwards as you have going forwards, and it would take a tremendous amount of fuel. Not to say that we'll never do this. Maybe one day we will, but NASA tends to do a flyby first, to kind of test the water. Right? Why not orbit? The same thing. You know, we'd have to slow down a whole lot. Yeah. You know, Pluto's like what, 1,400 miles across, so it has a very low escape velocity. We have to go very slow to be able to stay in orbit around it. Well, we land there. I hope one day we do. That would be incredible. Send humans, sign me up. I'll go. Right. Could there be life on Pluto? What do you think? Okay. Yeah, it's really cold, so life there is going to evolve very slowly. But you know, here on Earth, we're still finding new life. We're finding extremophiles. We've kind of changed our definition of life, what life is. So perhaps there is something that we may consider life there. We're still looking on Mars for life, for evidence of life. So it's something that humans like to do. Number 3, why not go closer to it? I can answer that one. I have this on the next slide. Okay. If you notice, we already talked about the fact that it's 1,000 times dimmer on Pluto. So these people around the world took pictures at twilight. Noon on Pluto is about as bright as twilight here on Earth. So they had to optimize the distance that the spacecraft, that New Horizons spacecraft was from Pluto. Because it's so dim, they had to open up the exposure, they had to open up the shutter on the camera for a long time to take images in the low light setting. But if they got too close with the shutter open for a long time, they would have just a big blur. So they had to get just far enough away where they could get a good image and not have it be blurred. So they optimized the distance of the flyby. Okay. All right, so on the way to Pluto, the images got better and better and better. As soon as they started downloading images, the geologists got excited. Oh, I see a mountain. Oh, I see a valley. They didn't see anything. They saw a big blur. But as they got closer, things did start to emerge, and they were able to see some detailed features. Okay, so the big day, mission success. They found out that the data storage was full, and New Horizons did not hit any debris. The crowd goes wild. As you can see here, this is Fran with her hands in the air screaming. She's the co-investigator. All right, so this is what they see. Okay, remember the red image, the best one that we've ever had? It looked like a smeared ball. Look at this. A complex world made of ice, and it looks like it has a heart. See that? I've heard some people said it looks like Snoopy, like his nose is here, his ear will be here. So it's an amazingly complicated surface structure. Has what looks like a white heart. And informally, they named this white heart the Tomball Regio, after Clive Tombaugh, the person who discovered Pluto. Okay, so a day on Pluto is 6.4 Earth days. When they flew by, they only flew by one side of it. So Tomball Regio was what they were focusing on. This is the clearest part of the image. Everything else is kind of blurry. Okay, they're still downloading data. It's going to take a year total to get it all back to us. So we'll get it until fall of this year. So there may be another update. There may be better pictures coming. So ice. Okay, it turns out it's half the density of rock. It's consistent with a third ice and 2/3 rock is what they think it is that they've flown by. They know that it about 180 miles deep from the surface is ice, mostly water ice. And the cool thing is at these low temperatures, water ice acts like rock. It's as hard as rock here on Earth. These aren't the only ices, though. Okay, there are nitrogen ice, methane ice, carbon monoxide ice, and these are all volatile substances, which means they sublimate very easily. They turn directly from a solid to a gas, and that means they can move around and they can go into the atmosphere. And you can see the distribution of the volatile ices, green, yellow, and magenta here. They seem to accumulate in the Tomball Regio. Okay, and the water ice accumulates in the darker areas, and it's covered in this black stuff. You have no idea what the black stuff is. So that's, hopefully more information to come on that later. Okay, so you can see there are impact craters. There are cracks from freezing and warming. There are frosty edges at the high ridges of the impact crater rims. The white rims of the impact craters are methane ice, and they change seasonally. You can tell when ices are new because they're very reflective and white colored. When they're older, they become duller. Okay, so the rectangle that's in the left ventricle part of Tomball Regio is called Sputnik Planum. It's a depression that's filled up with ice, and it's named after the first man-made satellite to orbit the Earth, the Soviet Union satellite Sputnik. And then over here to the right is a high-resolution strip. It shows nitrogen ice plains at the bottom. There's water ice mountains at the top, and impact craters at the very top here. And when you see impact craters, you know that that is an older region than an area without impact craters. So this is an older surface up here. Okay, and so like I said, the water ice is as solid as Earth rocks. So we can see in this picture water ice mountains, and they stick up as high as the Rockies, thousands of feet high. And the water ice, since it's less dense than the volatile ices, it floats. So you have floating rocks of ice. Okay. And then you have nitrogen ice that flows around. The arrows show it flowing around ice mountains into an older crater. And okay, we have these polygonal features up here in this photo, and then at the bottom it shows a cross section of the convection process that's happening underneath those features. So it looks like they turn very slowly, like over 500,000 years they will turn over once, and they will refresh the glaciers of nitrogen ice that are above. Okay, and these are some funny features. They're made of water ice, and they're in the middle of these plates where convection cells meet. And these features here, they're pits or they're cells. They're quite large. If you notice the scale, this is 20 miles, so these little pits are maybe the size of small towns. And you know, they're not really sure. On Earth, we don't have geology this cold. So we can't look at things like this and just know what it is. But they try to find comparisons to Earth. I think that maybe it's similar to penitentiaries or sun cups. These happen on Earth when there's old snow. So they think maybe these pits are this old ice behaving the way old ice does. Okay, and this, I'm sorry. Okay, this is the spacecraft arriving at Pluto and Charon. I can go back again, play it again. Okay, ready? All right. Okay, so this is New Horizons arriving at Pluto and Charon. You can see the sun illuminating the atmosphere. Okay, so this is what they found. They found hazes. Okay, on Pluto, they found that the sky is blue like it is here on Earth, due to the same reason, because it scatters blue light more efficiently than other colors. And so another thing they found when they looked at the occultation of the sun by Pluto is that sunlight reacts with methane to make more complex hydrocarbons in the atmosphere. So this is a lot like the behavior of Saturn's moon, Titan. But there's a lot less pressure here, so there's a lot less of this material in the atmosphere. But there are aerosols, and they are hydrocarbons. Okay, and these hydrocarbons are further combined to make bigger, more complex hydrocarbons, and they're called tholins, which is a term that Carl Sagan came up with to explain these exotic hydrocarbons that we find in the atmosphere of solar system objects. Okay, so this is a lovely picture looking back as New Horizons left the system. You can see the haze layers. Sputnik Planum is to the left, and there are tall mountains to the right. Okay, and this is a close-up picture of the water ice mountains. And there's layer upon layer of hazes and aerosol and nasty hydrocarbons up in the atmosphere. These things are terrible. If you were to go there and breathe these things, you would just, it would not be good. Yeah, exactly. Okay, so this is one of the weirdest surfaces you'll probably ever see. They call it snake skin, for lack of a better term. But it's these strange ridges that are made of methane ice when they're carried around over the seasons, maybe because of wind. But it forms ridges on the methane. Again, they're not sure of what forms these things. Okay, and there are ice volcanoes. Deeper down, because of the higher pressure, deeper down below the surface of Pluto, nitrogen or methane can become gaseous and shoot out of the whole of the volcano. They're not sure how it works, how they form, but they're huge. This one at the bottom here is 3.5 miles high, and one at the top is 2 miles high. Okay, and they were expecting this one to look like Sirius, like just a round rock. So this was a great surprise. Okay, even Charon has complex geology. Okay, it has water ice on its surface. It has a big crack that goes all the way across the moon. They don't know what causes the brown stuff. It has a red splotch up here that may be something that came from Pluto in the form of sublimation. And this is Charon and the small moons of Pluto. So Charon's at the bottom and the smaller moons are right above. Okay. And I'm gonna have a video, or an animation rather. Okay, ready? Okay. So these moons have strange orbits. The small moons are spinning very fast. They don't know what causes the tumbling motion of them. Perhaps it's left over from some impact. And these moons are too small to gravitationally cause themselves to become spherical. The smaller moons, they remain in odd shape. Okay. And NASA has approved the extended mission at this point. New Horizons is going to fly by another object, Kuiper Belt object Jim Green. Okay. And Jim Green is the head of planetary science at NASA, so they named it after him. So he might give some money for the extended mission. His real name is KBO 2014 MU69. That wouldn't give him any money. So Jim Green is the money. Okay, and scale, this is Pluto, and size of like a ping pong ball is Jim Green. So why do they want to look at such a lengthy little object? Well, Pluto, like we talked about, it's gone through all these processes. It has volcanoes, it has convection. All this material has changed its process. Perhaps Jim Green is an original planetesimal. Maybe that is what the material that made Pluto looks like. So it'll give us a look into the history of Pluto and perhaps other solar system objects. Okay. What a ride. Thank you very much. Any questions? Yes. Uh-huh. Yeah. Okay, that's an excellent question. So plutonium-238 is a byproduct of refining uranium into weapons-grade material. So this it's just one of the leftovers, and all it does is it just emits heat, and it has a half-life of 70-ish years. So half of the sample will continue to emit heat for 70 years. Half of what's left of that will go another 70 years. So it's going to be producing heat probably longer than the life of the mission, by a long shot. But it's not. It's undergoing radioactive decay, but it's not like a hazardous material that's going to. They can be weaponized. So what are they going to do with it? It's going to go off into space. It's going to keep going off into space, far away from our solar system, and eventually it will turn out to be lead after it continues its decay. Yes. A pioneer. Yeah. They don't do that with everyone. It's true. That was an idea that Carl Sagan and Frank Drake had. They thought since we're sending this thing out into space anyway, if an alien were to pick it up, we would like to send a message to them. But the chances of this thing being encountered by anything is just nil. So at this point, this is a lot smaller mission than Pioneer and Voyager. So they're very worried about weight. So any weight that they put on, and that's the case with most modern missions, especially when they rely on hydrazine, like this one, to make course adjustments. Any mass you have can reduce the amount of data you may bring back. Either if it's because it allows you to have less instruments or make less course adjustments, it's not, the payoff isn't worth it. Now that I say that, the aliens will probably catch this thing and they'll ask where's our plaque. so I think that's the reason why. Yeah. Yes. Okay, so if they were swung out by Jupiter using this new modeling, it would take planetesimals, which planetesimals are the building blocks for the solar system, so they contain everything that are on all the planets and that the planets are made out of, including water. So when Uranus and Neptune were ejected outward, they would take planetesimals, scatter them out into the Kuiper belt, and also scatter some inward into the inner solar system. So you could have water that had already condensed in the outer solar system get pushed back in. And that would be a good explanation for water on Earth, Mars, and possibly an early Venus. Venus has water, it has had water in the past. It's difficult to come up with a model where we would have water on Earth as a result of the sun ejecting that water, or that water just surviving in the disk around the sun as a liquid. So, one of the more reasonable ideas for a very long time was that perhaps a comet hit the Earth. We know that something about the size of Mars hit the Earth early in the Earth's formation and knocked loose the material that later formed the Moon. So it was very tidy to say that perhaps it was a comet that would have knocked the Moon material loose and delivered water to Earth. And since there's amino acids and the building blocks for life on comets, it would be a good explanation for why we have life on Earth as well. Well, they landed on a comet last year, I think it was, and looked at the water, and it wasn't the same water we have here on Earth. So that whole beautiful theory, down to catastrophe for it. So we have to go up with a new idea. This has been, they've been kicking this around for over a decade, that it's an alternative. It's an alternative theory that would work. Condensation theory relies on a lot of catastrophic variables, and we don't like that when we're coming up with explanations of how things happen. For one thing, they think that Mercury possibly, two planets collided and gave Mercury, made Mercury have a very big core. Okay. Venus is spinning backwards and slowly. Well, obviously something hit it and made that happen. Uranus is on its side and spinning with its pole pointed at the sun. Clearly something hit it and made that happen. Mars used to have an atmosphere, used to have water, now it doesn't. Some catastrophic event broke Mars. So out of 8 planets, 4 of them are the way they are because of catastrophes that don't fit into our best theory of how the solar system formed. So people are trying to consider other ideas and maybe come up with, maybe not even replace condensation theory, but refine it to where it's more reasonable. Any other questions?